Hello everybody and welcome back to question number 4 on the 2002 Fermat paper put out by the University of Waterloo. Question number 4, they come up with these questions every once in a while, just which of the following statements are true, which of the following are not true, that sort of thing, which of the following are always positive, that sort of question. And question 4 is exactly one of those, which of the following statements is not true. So a lot of these will be true. We just need to work out which one isn't. And it just relies on our knowledge of math here. So we go through the statements one by one. You can go through them very quickly in your head, but obviously we're going to explain them a little bit. So A, 25 is a perfect square. Well, can we write 25 as the square of some number? Yeah, 25 is 5 squared. So this statement is true. Now we're looking for the one that's not true. So all we need to do is find that one false statement. So we'll find our false statement, and then if it's not at the end, I'll go through the other ones as well just to explain. So B, 31 is a prime number. Okay. So I usually recommend there are certain sets of numbers that you should know. For example, I usually tell people you should probably know your squares up to 20 squared. You should probably know your cubes up to 10 cubed, things like that. These are just numbers that you should know, especially on the Fermat paper. That's grade 11 stuff. You should know some of these things just from experience by now. And another one is the primes up to 100. So 2, 3, 5, and all the way up to, then it goes 89 to 97, and those are the last two, just before you hit 100. Those are good numbers to know. If you want to know more prime numbers, more power to you, but I usually say you should know the primes up to 100. As I recall, there are 25 of them you should know. I'm not going to go through them right now, but 31 is among them. Now, if you didn't know whether or not 31 is a prime number, you can always grab your calculator and say, well, 31. If it's not prime, then I can divide it by another number. And so, in fact, we can divide it by another prime number. So let's think about prime numbers that are less than 31 and try and divide 31 by that. So 31 divided by 2, well, that didn't work. 31 divided by 3, well, that didn't work. And you can keep going and keep going. And if you know a little something about this, you actually only need to go up to 31, the square root of 31. So that's a little over 5. So you just need to divide it by 2, 3, and 5, and you'll be able to confirm 31 is in fact a prime number. So there's not a whole lot that we can write down in our notepad to explain this, but 31 is prime. 2 does not divide 31, 3 does not divide 31, 5 does not divide 31. Okay, how about C? What's C say? 3 is the smallest prime number. Here, another example of where our knowledge of prime numbers comes into play. Is 3 the smallest prime number? Well, actually, no. There is a smaller prime. Three is the smallest odd prime. 2 is smaller than 3, and it is a prime number. We just mentioned it up there. So this is our false statement, and as soon as we saw this, as soon as we read it and identified it as such, we could bubble in C and move on. But let's see why D and E are true. 8 is a perfect cube. Well, this is another example of numbers that I usually recommend people know. It's probably one you've encountered before. Is 8 a perfect cube? Can we write it as something to the power of 3? You bet we can. It's 2 to the power 3. And finally, E, 15 is the product of 2 prime numbers. Well, what are the factors of 15? What ways can I write 15 as a product of 2 numbers? Well, I could say it's 1 times 15, but those aren't prime. But I can say that it's 3 times 5, and both of those are prime. So that is a true statement. So C is the one that's not true. C is the one we bubble in. Okay. So that does it for question number 4. I'll see you guys for question number 5 on the 2002 paper in the next video.